Harish Kumar S. In my last session video, I was discussing about SMPS introduction and their types and so many theory points about the SMPS. In this session, in my second session video, I am going to discuss about each individual type block diagram in depth. Okay, and one of the type is one of the most famous type in SMPS is what I was discussed previously. That's a DC to DC converter. Guys, let's come back to block diagram explanation. This is the DC to DC converter, SMPS block diagram of this. And one more point, first of all, I'm going to in depth of that. I want to mention few more things and very important things about that. Only two sections are there. So I'm going to divide two sections. Those is a primary and a secondary. These are the two mainly types of my explanation. Okay, and why we are going to divide? This is a primary and this is a secondary. Okay, let me explain this case. So this primary case, this primary is a hot area. Hot area means this is the high power. That means not a high power, it's a high voltage, and it's a very dangerous case which was directly interact with a line. That means whatever we were given supply, input supply. And this is the secondary, which was converting voltages and outputs were taken at this stage, and this was what we are given to our load. Okay, and then we mainly provide isolation between a secondary and a primary. Okay, this isolation. There's no actually electrical connection between a secondary and primary. And let me call this is a hot ground and this is a cold ground. Okay, whatever your voltages may measure in this case, we have to measure according to with that voltage only, with that ground only. Yeah, that's the concept. It's a hot ground and it's a cold ground. And let me indicate a hot area in this red marker. Okay, this is the input what we are given to our supply. Either it's a 230, 120 with the different sections. Okay, this is the area where we are rectifies our AC signal to the DC. That means bridge, either it's a bridge rectifier, a half wave or full wave, anything. So we usually use bridge wave rectifier in this case section. And one more block is there with that's a filter section, and this stores the main DC, and this is technically called as DC bank also. This is again fed to our switch. Okay, then this whatever we are given supply is given to our switch. Okay, this is the import section, and let me denote our cold area and our controlling area, controlling lines with my blue pen. This is where the control systems provide. Okay, PWM oscillator and a driver for this switch. This switch is nothing but our either it's a BJP, MOSFET, or any switching device which converts power with switching. Okay, and then this whatever supply is there, that is given to our switch, and that is connects to our the input transformer. Mainly our SMPS is converts high voltage to low voltage only. Okay, when my PWM pulses are fed to my switch, this starts switch on and switch off, that converts to power. And this is a transformer where this converts our energy from primary to secondary. This is a secondary coil. And one more important point is switching frequency. Usually our switching frequency is a 15 to 50 kilohertz. It's not in hertz, it's in a kilohertz. Okay, let me come to secondary section. Let me indicate secondary section is with my yellow. Okay, that means it's a cold area. Okay, this is the output section where we takes our voltage at this section with a buck section. Okay, this is a rectifier, and these rectifiers rectifies with a high frequency voltages, and that's usually within 24, 15, 5 volts standard voltage, 3.34 volts. These are the standard voltages. And this is the section where we takes sense from output. That means output section, how much is current drawing. Based on that, this is the sensors. Okay, based on that, we are takes from isolations to our PWM correction. This is the where the feedback section. This is where the our feedback section. Okay, we take sense from output, and that is our given to our isolation components. That means it's either kind of opto isolator, transformer, or it is any kind of electronic device which converts from isolation methods to power. Okay, this converts power from secondary to primary, and this is a signal where you are given to this, either it's a error amplifier, it's a error correction, everything is inside in this block. Okay, we will take some reference voltages, and that is compare with this our feedback input, and that is makes our PWM. Based on that, we are going to vary our pulse width. So if your maximum pulse energy transfers at 50% your pulse width, this is the concept of DC to DC converter block diagram.